this is modern physics, final exemplar. This is question 2. This question is asking at what distance from the nucleus is the electron most likely or probable to be located in the 2p state of the hydrogen atom. Then we want to calculate the average location of the electron and compare to the most probable location of the electron. We're going to explain what these calculations tell you about the location of the electron in the 2p state and consider plotting the radial probability density to help make sense of your work. So starting with the most probable, we know that P of R is our radial probability density, which equals R squared times the absolute value big R n of L squared. And in this case, we know that R of 2, 1 over root 24 A naught to the negative 3 halves and then R over alpha naught E to the negative R over 2 alpha naught. So when we're doing this equation, we want to do P of R equals R squared times 1 over root 24 A naught to the negative 3 halves R squared over A naught squared E to the negative R over 2 alpha naught, all of that squared. And then simplifying this, we get R squared um, one over 24 A naught cubed R squared over A naught squared E to the negative R over 2 alpha naught. Alpha naught. And then we can further simplify that. So then for this, for most probable, we want to take the derivative to get the most probable location in terms of R. So we're going to say d partial dr of all of this stuff with an R in it. So I can, none of that has an R, so I can cancel that. Of basically R to the 4th over A naught squared E to the negative R. Oh, that's not what I wanted. We wanted R to the 4th over 24 not to the 5th E to the negative R over alpha naught equals 0. This becomes 4R cubed 24 alpha naught to the 5th 0. Both of these have an e to the negative r over alpha naught. So we have 4r cubed we can also cancel the 4 and the 24. Finish with r cubed over 6 alpha naught to the 5th minus r to the 4th. 1 over alpha naught equals 0. And then that can essentially be canceled because they both have it. So then we get r cubed we can pull out r cubed 6 alpha naught to the 5th. Both of these, be left with 1 minus r over 4 alpha naught equals 0. That's canceled, so 1 minus r over 4 alpha naught equals 0. 1 equals r over 4 alpha naught. So then 4 alpha naught equals r. So 4 alpha naught is our most probable location of the electron in the 2p state of the hydrogen atom. Now, to find the average location, we have that r is the integral from 0 to infinity of r p of r dr. So that becomes the integral infinity of r dr equals cubed r to 1 squared dr. So then solving this integral, we have r cubed 1 over 20 naught 24 naught cubed r squared over alpha naught squared e to the negative r over alpha naught all integrated over r. So we can pull out our those values. And then r 0 to infinity r squared e to the negative r over alpha naught. Sorry. R to the 5th. So then, by rule, we know that if we have an x to the n e to the negative ax power, that equals n factorial over a to the n plus 1. So we can plug this into here. So then we would have 1 over 5 factorial, and a here equals 1 over alpha naught. Sixth. Fifth. Equals so we cancel that, cancel these. Goes with 5. Five alpha naught as our average location of the electron. So now, if we want to graph the radial probability density, that's our radial. So for a radial probability density graph, we'd have radial probability density on the y, our distance from the nucleus on the x-axis. So we're going to plot our most probable at 4, and then we have the average at 5. And then a distribution of this, it's gonna peak and it's gonna come back down all the way here. The values for the most probable location and the average location of the 2p state of the hydrogen atom tell us that the electron in this state is skewed because the probability density peaks at the most probable, where we're at 4 alpha naught. And then due to the long tail, the average is actually slightly over to the right, even though our average is a little bit less. So, yeah. This does make sense though, due to that long tail, and that is why our most probable is 4 alpha naught.